This is TWiT.
Okay, speaking of things that you really wish you could keep secret, but you can't, Rockwell Automation has a CVE 2021 number 22681. It is a 10 out of 10 critical, assigned by CISA. The security of nearly all of Rockwell Automation's PLCs, which are programmable logic controllers, are affected by the use of a single globally shared static encryption key. Oh, yes. Every one of the, now I wrote hundreds of thousands, it's probably millions. I mean, these things are everywhere. I'll explain what PLCs are. But they're all protected, in air quotes, by the same single key. So, of course, there just might as well not be one. So a programmable logic controller fills an important gap within any process control system or an important need. Yeah, for example, you might be on an oil rig where the pressure of a feeder line, and I don't even know what that is, but it sounds good, a feeder line must be maintained within a range. But the pressure might need to be taken at several different places and averaged. And there might be multiple upstream sources of pressure controlled by valves with actuators. So in a sense, it's a small closed system having a handful of inputs and outputs. And once its function is defined, it can and should just be left alone to work. You just want that feeder line pressure maintained, and if you got to open some valves using actuators to maintain the pressure, then that's good, and you want to average the pressure in a few locations. So, you know, not a big complex job, but it's a job that needs to get done. So, how do you build the control system for that? Once upon a time, before computers, a custom circuit would have been created and some tech would have built it from scratch. Today, you go over to Rockwell Automation's website and pick the PLC, the Programmable Logic Controller, that's just big enough to, because there's a whole bunch of them of different sizes, you want the one that's just big enough to handle the number and types of inputs and outputs that you need. Then, an engineer who's been trained up uses Rockwell's software, which is called Studio 5000 Logix Designer, to program the little computer that resides inside that industrial oil rig tough little box. And you hook it up, and you know, that little world will now take care of itself. So a PLC does a limited set of very specific things. Once upon a time, as I said, it might have been done with discrete circuitry, you know, like a bunch of clacking relays all wired together to implement the sequencing logic required to route vials of newly synthesized vaccine around their carousel, counting them as they pass, and then to flip routing gates open and closed at the exact time needed to fill the waiting containers. Another typical job for a PLC. But today, all of that is handled not with a bunch of clacking relays, but by an unseen Rockwell Automation PLC. It's programmed once, and it effectively becomes part of the overall machine. In any industrial setting where things are moving, spinning, whirring, valves are opening and closing, and stuff's happening, there are tasks that don't require a general purpose computer. And God knows you sure don't want Windows anywhere near the control loop of systems like that. You know, it'll decide it's time to update, and, you know, your vaccine vials will go flying all over the place. So, you know, yes, Windows hosts Rockwell's Studio 5000 Logix Designer app, which is used to, in a cool way, to interactively design the logic that will be programmed into this. But once that PLC device is programmed, it's blessedly off on its own. Leave it alone. It'll just get the job done. So everything would be great with these workaday PLCs. But apparently, some bozo somewhere decided that needing to go down to the shop floor to tweak the controller of the machine that's squeezing bottle caps onto Coke bottles was too much to ask. So let's put it on the network. Yes, believe it or not, these perfect little happy worker controllers have received IP addresses. Stop me if you've heard this one before. What could possibly go wrong? And yes, as I mentioned above, not only do they have IP addresses, often with public presences on the internet, again, things that are just supposed to get their job done, just leave them alone. They're working. But they are all being protected by the same now well-known cryptographic key. Last Thursday, the US CISA warned of a critical vulnerability, giving it a 10 out of 10, which is a hard score to earn, that 10. You can get to 9.8 without trying that hard. But getting a 10, it's like the Olympics. So that allows hackers to remotely connect to Logic's controllers and from there alter their configuration or applicable code. CISA stated that the vulnerability requires a low skill level for exploitation. Quoting them, they said, the vulnerability tracked as Cve-2021-22681 is the result of the Studio 5000 Logix Designer software, making it possible for hackers to extract a secret encryption key. And they didn't put secret in quotes, but, they said this
semi-secret.
Yeah, we wanted it to be secret. So could you please let's keep it a secret, everybody. Let's agree. This key is hard-coded into both Logic's PLC controllers and engineering stations and verifies communication between the two devices. A hacker, they're writing, who obtained the key could then mimic an engineering workstation and manipulate PLC code or configurations that directly impact a manufacturing process. It's just, why must we put everything on the internet, Leo? We just,
Because it's there, Steve. Because it's there.
But, people's garage doors are on the internet. And I mean, if it moves, hook it up.
Yeah.
Give it an IP address.
That's it.
My
garage door is on the internet. Is that a bad thing?
I really didn't mean to pick on you, Leo. Yes.
It makes it easy to open it from anywhere.
On the other hand, I should have said, of course your garage door is on the internet.
Is.
We know your front door is on the internet.
No. Well, it is. Pick the camera. Yeah.
I know.
You're right.